Welcome back to the Second Law of Thermodynamics. Today, we will continue our lesson on entropy calculation. On the previous video, we already calculated for entropy using direct calculation. It is delta S is equal to S of your products minus S of your reactants. This time, we will calculate for entropy's dependence on temperature. Let's derive our equation. Here we have delta S is equal to delta Q over T. What are the formulas that could be used to calculate for Q? We have mCp delta T and or m times the enthalpy of vaporization or enthalpy of fusion. Since this time we are calculating for dependence with temperature, we will be using this equation. Therefore, dq will be equal to mCp dt. Now let's substitute this value. Therefore, we have delta S is equal to mCp dt per T. And we will get the integral of dt over T. You will get delta S is equal to mCp ln of T2 minus ln of T1. Or if we simplify using the laws of logarithm, you will have delta S is equal to mCp ln of T2 over T1. Now let's proceed with our examples. What is the entropy of a system when 45 grams of water was heated from 30 degrees Celsius to 310 Kelvin? So M is 45 grams, T1 is 30 degrees Celsius, and T2 is 310 Kelvin. So what will be the Cp that we are using? So this will be 4.184 joules gram degree Celsius. So we have delta S is equal to mCp ln of T2 per T1. 45 times Cp times your ln of T2, it's 310 minus 273 over T1, which is 30. So what will be our delta S? 45 times 4.184 times ln of 310 minus 273 over 30. So we have delta S equal to 39.4862 joules per degree Celsius. Let's have another example. So calculate the entropy change when 1 mole of cadmium vapor is heated from 1040 Kelvin to 1100 Kelvin. You may assume that the vapor follows perfect gas behavior, and we have Cv equal to 12.5 joules Kelvin mole. Sometimes if you are not given your Cp, Cp is interchangeable with your Cv, and your M is interchangeable with N. Therefore, S is equal to N Cv ln of T2 over T1. Delta S is equal to 1 mole times 12.5 joules Kelvin mole times ln of 100 divided by 1040 Kelvin. So what is our delta S? Delta S is 12.5 times 1 times ln of 100 divided by 1040. So delta S is equal to 0.1011 joules per Kelvin. Did you get that? So let's summarize the formulas that we know so far. Direct calculation is delta S is equal to S of your products minus S of the reactants. And entropy's dependence on temperature is signified by delta S is equal to mCp ln of T2 over T1. For the next video, we will be looking over entropy associated with phase change. Thank you very much. If you have any questions, please post them on the comment section below. See you in the next video.